So moving on, how does AI and big data work together? So first and foremost, to train an AI model, you need a large volume of data. That data has to be of different types, what we call as the variety in the data. The data also will be coming in, with a lot of speed, velocity. So I'm referring to 5 V's of big data, right? AI-powered models need that data to be ingested before they can actually become usable. Next, how big data, once models have been trained, how can they help big data? So how AI helps big data now? So that is via unlocking insights. A lot of AI-driven models, let's say NLP or data mining strategies, they can be used to glean insights from the data which might have been missed by a human eye. So you can use AI to mine that data and get you insights which probably we never thought was there. Next, automation. Today, AI is at a stage where we can automate a lot of tasks which a data science engineer was doing manually earlier. For example, data labeling. Very simple. But this in turn helps the data science engineer to work on something which is more complex and which is more relevant, which cannot be done by the AI today. Then AI and big data, once they are trained, they become a prediction powerhouse. We have had models deployed for many of our customers running live in production, and they have been giving great accuracy, almost 95% and above. This helps the businesses to take informed decisions in terms of customer behavior as well as any internal business decisions. Next, the model over a time, as we all know, will slowly start drifting. So to keep that model to the level of accuracy that it was trained for, you need to continuously upgrade that model. That upgrades again requires a lot of data to be fed back into it. This data could be coming in form of new data, so that models continues to upgrade. Secondly, the feedback of the existing predictions or existing results that the model is giving, those also need to be given back to the model to understand where it was missing and help it become more accurate. Last but not the least, with the advent of generative AI, a lot of time we have also seen was the data was not sufficient enough to train a real good accurate model. The data was lacking. So with the advent of generative AI, we can now think about generating synthetic data, which matches the same, I would say, statistics of the data on which it was being trained. Alright, so where does now Ksolves fit into all of this? So, like I said earlier, we are into software services. I have people who are experts in all of these technologies. I have people who are big data architects, people who are machine learning architects, machine learning engineers, data science, data engineers, big data developers, ETL developers. We are a almost 500 plus strong group. What we bring to the table is we can lay that groundwork for you to ingest that data as per your requirements and develop models on top of that. So what I mean by that? So let's say you have a use case and you need, you have, let's say, so this is a solution that we propose. It's something on which our demo is also running right now. What we have over here is we have data which can be coming from different sources. It could be your POS, it could be your social media, it could be your internal applications, internal CRMs, anything. That data needs to be ingested into a usable form for further training. When I say that, so you need to have, let's say, your ETL developed. That could be done via different technologies. It could be done via Kafka, it could be done via NiFi. You could be doing batch streaming, real-time streaming. That data then needs to be stored into a data storage. That storage could also be of different types. It could be a data lake. You could also think about using HDFS for distributed systems. Then it could be SQL, NoSQL, and now because GenAI, it could be a vector DB. So we need to develop an ETL to ingest this data, bring it to this data storage. At the same time, the data needs to be kept secure. It should be accessed only by those who need. It should be audited. Everything should be properly monitored. So there's a good part of data security involved. Then over time you also need to maintain the data governance. Where this data came from, how was it updated. The data, what we call as lineage, the data catalogs, the data metadata, all coming under data governance. So this is, so once this is achieved, so once you have developed your pipelines to ingest the data into your data storage, following all data governance, all data security, then you can build upon this data to power your AI analytics platform. Now that platform could be running in-house. So that platform could be running in-house. It could be, you could be using, let's say, any managed AI-powered system, for example, SageMaker. If you could go to Google, you could use Vertex AI, right? Or you could do all of this on-premise. All of this needs to be monitored. So there is a concept of AI ops or ML ops also. And then, if you are dealing with generative AI, you have to think about your deployment of LLMs also. So once your model is trained, model is deployed, and it is ready to serve, then comes your data consumers. So you could use this data for driving, like I said earlier, any business-related decisions, or you could expose it as an API for external consumption. And then, lastly, the data visualization, where you can see dashboards, you can run Power BI queries on top of it, or even generate custom reports. So what you see over here, we have people who are experts at each of these individual components. So this all solution can be run as a platform. It can be run as a, maybe on your on-premise, on cloud, however you want it. Like I said, we have a demo which is built over top of this solution and running live. Another thing, we believe in open source. So all of this that I have shown over here, it is right now running on open source technologies. If there is any use case wherein you have, so some of customers may have external proprietary softwares, that can also be included on top of this. Alright, moving ahead. So, like I said, we have some case studies to demonstrate. The first case study is about an edtech, and they were looking for, so they had a challenge. So this edtech is actually a US company. They have multiple products, but one of their major products is being deployed in Australian universities, and it is like so when a professor is streaming his lecture, that lecture can be streamed live to different students. So the client, this company was looking for a solution wherein they can use generative AI into how do they integrate generative AI to make the job of the professor easier. And one of the use cases that came up was that during the lecture and after the lecture, the students needs to be tested on what all they have learned. So the professor had to create assignments, he had to create some exams, he had to create some assessments manually and then send to the students. This was one thing which was a very good fit for generative AI, and the difference was the LLMs which are available, they have not seen this data. So this data needed to be fed to an open source LLM, customized for specific lectures, and then use that LLM to generate these assessments and questions. We work with our customer. This data was in different formats. It could be documents, PDFs, even videos. And we have customized that LLM. It has been fine-tuned specifically for this. And today it is live and serving our customers very well. So it is able to understand what the lecture was about. It is able to analyze from that lecture which points were which need to be more stressed upon, because every lecture has some points will be more critical, some will be less. So it can detect which ones are the most important ones, and based on that it generates the assessment specifically. So this is a high level diagram for that deployment. So the first was the data ingestion part, wherein we had different type of documents, it could be PDFs, different type of documents. They were ingested into a data lake. Then we had LangChain read those documents, create them into chunks, develop a vector, and fed that, and what that vector was saved into a vector database. We had used Cassandra over here. Then, when when we have to generate any questions on top of that, the query that came from the front end, that was again, it was first broken into embeddings. Those embeddings were then sent to the vector database to get the matching vectors, which were then used with a prompt template to get the actual response from LLM. The second case study is about another client which is into cable modem network, and they have millions of these cable modems deployed across US. So they were looking for a solution wherein, so they had a challenge wherein these cable modems, they connect to a CMTS, and it's like if one of the CMTS is showing a problem, that problem can it be identified proactively, because if it leads to a fault in the CMTS system, hundreds of users will be affected. Imagine if you have one of the major hub going down, all the users connect via that CMTS server, they will be losing internet connection in their home, and which is a very bad user experience. For this, they used to send technicians, to fix that problem. But if that could be done proactively, so we worked with them. The biggest challenge over here was that there were millions of modems, and they had to be called for a lot of data, and there were almost 150 to 200 features, data points that were being called from modems. Out of those, we had to decide which ones were the most useful to be used as a feature for training the model. So we worked with them very closely. We understood how each of these data points means in terms of a modem. So it could be signal strength, it could be bandwidth, input, output. So our model. So one was this requirement from them. The other was they wanted a smart bot also. It's like a smart assistant which could help the technicians answer any queries, as well as also help manage customer queries. So we work with them, We understood the modem specifications, different models, and we built a pipeline which can ingest data of these almost more than 1 million modems. And then we trained different models actually. And out of them, we identified that the model which was, it was a boosting algorithm which I believe we used, that helped give the best accuracy. So this is a result of that. The modems were color coded based on the confidence score, whether there is good chance, whether there is a high chance of failure or impairment, what you call. The red dots show the modems which are which is a high chance of impairment in them. The blue ones are the ones which are right. The bottom diagram is about how we ingested data into an LLM. So over here we have used, because it was an in-house on-premise solution, so we have used Llama, and for vector storage we have used SAS over here.